Okay, so we're looking at question 4 here. It says consider the phase diagram. Now what's written there, or that diagram, is very standard phase diagram. About the only thing you'll ever see that kind of changes is sometimes this line that's going from B and kind of straight up will sometimes be angled at a backwards slope, so going back towards the y-intercept. But most substances like this one going up. So this could be almost any standard substance that has reasonable to attain boiling points, melting points, etc. Now this is typically all of them because the phases are kind of interesting. So this here is what we'd expect to be a solid. Solids at relatively low temperature. And think about water. As we warm it up, it does turn into a liquid, which is what this curve is here. And these guys down here are gases, which is kind of interesting. If I actually have water at a low enough temperature or low enough pressure, it will actually go from a solid right to a gas. Now we see that on dry ice, for instance. Dry ice, which is just CO2, as a solid, as it actually warms back up, it is down here at a different scale, and it will go right to a gas. So we always have these phases. Now, a few interesting points. B right there is what we call a triple point. If you're at that pressure and that temperature, the substance exists as a solid, liquid, and gas simultaneously. And this point, C, is another critical one, because technically if we go above it on the pressure or the temperature, it's no longer obvious if you're dealing with a liquid or a gas. We have substances that kind of look like both, or behave kind of like both. All right, so let's talk about our situation. And so the first question is, want to know what phase is present at A? Well, that is a liquid. And it's pretty much always this case. So if you imagine water, it's just going to go right across like that, solid, liquid, gas. And the only thing you sometimes lose is if we go down a low enough pressure, you might go from solid right to gas as you increase temperatures. All right, so what's present at B? That is actually the triple point. So we have solid, liquid, and gas all present there simultaneously. And C, what's the significant? That is the critical point. And past that point, you can no longer tell for sure if it's a solid, if it's a liquid or a gas. So liquid and gas behave the same above that point. And that's kind of above it with respect to pressure or temperature. All right, then let me erase all these markings here because this next one says, starting at D, if we lower the pressure but don't touch the temperature, what actually happens? So if we're starting right here and we just lower the pressure but don't touch the temperature, that's not a straight line at all. See what's eventually going to happen? That solid will eventually go to a gas.